right, welcome to notes number 7. We're going to begin here with the review question, the same one that was in the pod in the slide before this. So you should have already answered that. We're going to discuss that, and then we're going to begin talking about how the Earth, the Moon, and the Sun, even though they're all in the same solar system, how they're similar and how they're different. So to start off with, this is a review question from yesterday's notes with the water cycle. That was yesterday, right? Yes. So the question is, how do the sun and the ocean interact during the water cycle? Now, in the pod, I put the hint. If you're not sure what I mean by the question, what I mean is, what effect does one have on the other? Okay. How does the sun affect the ocean, and how does the ocean affect the sun, and vice versa? Okay, so the relationship between the two during the water cycle has to do with the sun will heat up the water molecules within the ocean, causing them to vibrate faster and faster, right? The more heat you add, the more they move. And eventually the atoms will begin to move so quickly that they will eventually break free from the ocean altogether and evaporate into the air. Right? Well, those evaporated water particles, let's pretend they're like steam, right? So my fingers kind of like this. Those evaporated water particles, okay, they come up into the sky. As they get higher and higher, they begin to cool. And when they cool, they perform the process of condensation, and all those water vapor molecules come back together to form back into liquid water droplets, okay, which will eventually come back down as rain and, into the ocean again, and then it will evaporate more, and we're back to condensation, and the whole cycle continues. So how do they interact? The sun heats up the water in the ocean, causing it to evaporate into the air, which will then cool into the condensation and kind of start the water cycle process. Ooh. She yanked that out of my ear there. Okay. So for today, we're going to look at each of the three objects that I just mentioned before, the Earth, the Moon, and the Sun. We'll start with the Earth because why not? This is where we live. If you don't know this, this is where we live. This is very important. Okay. The Earth is the third planet from the sun at a distance of 150 million kilometers, right? So that would be the distance from, if I could get my little pen, where's Earth? Here we go. From here to here on the picture, okay? That would be 150 million kilometers. A lot more than you think it is, okay? Also, we know the Earth revolves around the sun every 365 and 1/4 days. Don't forget that 1/4, right? That's what makes up leap year and gives us a leap day on the 4th year. So it revolves around the sun every 365 days and rotates on its axis once every, you should be able to fill that in without having the answer here in the slide, but rotates once every 24 hours. Now, Earth is a very rocky planet that is constantly being reshaped and reformed through 3 processes: weathering, erosion, and deposition. In our next unit, we're going to discuss those 3 processes, what they are, how they happen, and how they help shape the Earth. But for right now, just know that Earth is kind of like one big rock with divots and shapes and things in different places. But on the basis of it, even deep below the surface, eventually there is hard rock and land, right? Obviously, the closer you get, the further you go in, the closer you get to Earth's core. But the mantle and things like that I know you discussed in 4th grade last year, that pretty much describes most of the surface of the Earth. It's very rocky. Oh, that's not working. Okay. So one thing I wanted to show you, and I believe I also have this in the next unit when we discuss weathering and erosion more specifically, but if you look at the coastline in the picture on the left, okay, this is from, you can see the date up here, this is from September 6th of 2016. The coastline has a certain shape. Obviously, it has a little bit of a coast. This would be the coastal area. Once it gets darker, more green, that would be more of the hilly or maybe even forest type areas, okay? But we see this general shape along the coastline here on September 6th, 2016. Now, fast forward about 3 months to November 15th, 2016, and now we see the coastline looks a little bit more like this, Okay, it looks like the water maybe is a little bit shallower, right? But notice because the color is a little bit lighter, these are darker areas. Maybe that's a little bit deeper, but that also could just be shadows from the clouds above it. But anyways, right here, all right, where the three arrows are pointing, you can see pretty distinct differences from the picture in September and the picture in November. Okay, the coastline over here is a little bit bigger. All right, you can see this section of dark brown is a little bit thicker in this picture than it is in this picture. Okay, then we have the same thing here. This looks almost like a bay of sorts. Okay, so this is just one example of the coastline changing. It looks like maybe there was a drought of some sort, or maybe there's a tsunami coming, and so all the water is being kind of sucked away. But the coastline is revealed a little more here in the second picture than in the first. So this is just an example of how the Earth's surface is constantly changing. Overall, it pretty much holds the same general patterns and shapes, right? We still have all the countries and the continents. Nothing changes dramatically unless something terrible happens. But the coastline and the rock type formations on the surface change pretty frequently from year to year. The Earth has a diameter of 109 kilometers. That means that from here to here is 109 kilometers. Okay. Which is interesting because here it says the diameter is 12,756. I think in your notes, I actually have you cross this off. So let's go ahead and do that. In the notes that I printed off and gave to you, I want you to kind of mark through this number. I believe it is supposed to be the 12,756 kilometers. Now that I think about it, I think I remember that from last year. I'm not sure where the 109 came from, but anyways, 12,756 kilometers across. Now, Earth has a moderate temperature all the time. That means that it is pretty mild for the most part. Now, there are some very hot parts and there are some very cold parts, but when looking at the planet as a whole, generally the temperatures are pretty moderate, especially in comparison to some of the other planets in our solar system. Venus, for example, is very, very hot. And the general temperature, the general temperature of Venus is a lot warmer than that on Earth. So another characteristic of Earth that sets it apart from all the other planets in our solar system is that we have an atmosphere. Very, very important for us living creatures because we need that oxygen, which the Earth's atmosphere is made up of nitrogen and oxygen, and even has liquid water on the surface. Now, we have found frozen water, or at least evidence of frozen water on some of the other planets, but we have not found another planet, not in our solar system at least, that has as much liquid water as we do, which is incredibly important because the human body is like, I want to say like 97% water or something like that. So very, very important for us. And that's part of the reason why I believe we were placed on the Earth and nowhere else. Earth is the only place in the universe that has life. Every year I have some students that say, Ms. Horsling, what about aliens and extraterrestrials? We have not found definitive proof. At least I don't believe that we have. I think some people try to spin some things into thinking there's aliens. But anyway, that's a different debate. But for right now, the only place that we can confirm that has life is the Earth. We also know that 70% of the Earth's surface, that's about 3/4, is covered by ocean, which contains about 97% of the Earth's water. We discussed that in the water cycle unit. And Earth has only one natural satellite. Now, this word satellite here just means an object that spins around something else, okay, or revolves around something else. So, for example, Earth is a natural satellite of the sun. So is Mars, so is Jupiter, so are all the planets in our solar system. The Earth only has one natural satellite, only has one moon, which we call obviously the moon. Other planets have moons as well. Some have 2, some have 4, depending on how big they are. It just depends. But those could all be considered natural satellites of that planet. It just means to go around or revolve around something else. Now, this fact is actually extremely interesting. I love telling students this, but the distance between the Earth and the moon is so big that you could fit every planet of the solar system between them and still have 2,092 kilometers to fill. Okay, so this picture is showing you, actually, let me go back real quick to this picture. Okay, so we're talking about this tiny area, and it seems, at least in this picture, from here to here, from the Earth to the sun. It is actually so big that you could technically take every other planet in our solar system and bump them up side to side, like what you see here, and actually fit all of those planets in between the sun and the Earth, the distances between those two, okay? And still have 2,092 kilometers to fill, all right? This would be like, here's the Earth and here's the sun, okay? Even though it's only, what did we say, 93 million miles, something like that, you could still fit every other planet, smash them together, and still have 2,000 kilometers to fill. Now, what I like to point out about this, with this picture, my point in putting this in here is to understand the size of space. It is almost impossible for us to wrap our minds around, okay? On our Earth, it's still pretty big to say 1 mile, 7 miles, 15, 50,000 miles. That's a pretty long ways away. But in space, 1 mile is like nothing. Okay. The units, or the sizes that we use to describe measurements and sizes of planets and stars is just so unbelievably big that we really can't even wrap our minds around it. After we finish the lesson today, I'm going to include in the pod one of my last year's classes, one of their favorite videos I show all year. It's called the star size comparison video, and you'll get to see what I'm talking about, just how incredibly big some of these bodies are up there in the heavens. It's crazy to me. So that's our facts on the Earth. Now we're going to move on to the moon. This is a pretty good picture of the moon. It's also important to note that the moon does not create any light of its own. It's not a star. It's more like a mirror in that it reflects the light from the sun and other stars. Okay, so it does look like it's lit up to us, but it's not actually. It's really just reflecting all the light from the sun. Size-wise, the moon is about 1/4 the size of the Earth. You can see in this picture comparison here, the moon's much, much smaller. The moon actually revolves around the Earth every 27.3 days. So, it takes 1 year for 365 and 1/4 days for the Earth to go around the sun. The moon takes 27.3 days, okay? Which is why about every 28 days we have a new moon, or we have a new lunar cycle, right? With new moon, waxing moon, waning moon, half moon, gibbous moon, crescent moon, full moon, all those things, okay? So about 28 days for the Earth to make one complete revolution, for the moon to make one complete revolution around the Earth. Along with the Earth, the moon revolves around the sun. So what happens is, okay, let's pretend, can y'all see this? Kind of. Okay, let's pretend this right here is the sun, okay, my little gray straw here. If this is the Earth traveling around the sun, right, while also spinning, okay, so like spinning, going like this, right? Then we have the moon, which goes around the Earth while also going around the sun. So it makes kind of like circles like this, all right? So the moon is rotating as well as the Earth, but it does not rotate or spin as fast. But so you have the Earth, it's spinning while also revolving. Then you have the moon that's spinning a little bit, but also revolving around the Earth as it revolves around the sun. Kind of like this, if the sun were in the middle. Okay? The moon, just like the Earth, is made of rock, but unlike the Earth, it has no atmosphere. Okay, if you were to, if you wanted to land on the moon and you were in a rocket ship, okay, if this was the moon, if you were to stand on the moon, you would not be standing in the atmosphere of the moon. It has no atmosphere. You would actually literally be standing in space. Okay, it doesn't have this layer or like gaseous bubble that surrounds it like the Earth does. It has nothing. It's just space, 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 space. Now you're on the Earth. Okay, or moon, as opposed to space, 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 atmosphere, 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 then Earth, right? So the moon has no atmosphere while the Earth does. The only major factor that can change the surface of the moon is the impact of meteoroids that form new craters. Okay. If you look in the picture over here I have on the right, you see there's lots of like valleys or holes. It almost looks like divots, big indents in the moon's surface. So the moon's surface can change, but only when something hits it. It doesn't have rainstorms or earthquakes or volcanoes or things that can come and change the surface like we do on the Earth. The only way the moon can change is if something were to hit it or impact its surface in some way. The surface of the moon changes very slowly because it has no weather and no atmosphere. That's why if you were to go up to the moon in that rocket ship we were talking about, if you were to look on the surface, I believe you can still see the footprints of the first astronauts that landed on the moon because there's really no wind movement. There's no avalanche. There's no rivers. There's nothing up there to erase those footprints. There's no air. There's nothing. So once you make an imprint, it stays there until something else comes along and messes up the surface. Okay, it's pretty interesting. Last body we're going to talk about is the sun, and it is just as powerful as it looks. Okay, very, very important for our life here on Earth. You'd actually be surprised how much of how much of our daily lives revolves on either energy from the sun or impact from the sun, heat from the sun, on some level. Okay, I tell my own classes this. Sometimes when I start teaching in lectures and lessons, I get going so fast and I kind of forget to breathe sometimes and it makes me yawn or something. I don't know, but I always end up yawning when I'm teaching for a while, which is kind of crazy. Anyways, the sun. The sun is a star in the center of our solar system. Okay, it is not a planet, it is a star, meaning it is basically a burning ball of gas. And this is what creates the light for all the planets that orbit around it. Both the Earth and the moon orbit the sun. Okay, you can see in this picture what I was talking about here. So here's the Earth. It does revolve around the sun. Okay, while it's also rotating, it is spinning. Then you have the moon, which revolves around the Earth while the Earth revolves around the sun. So it does kind of one of these like corkscrew, is that what I'm looking for? Type movements, something like that. Both the Earth and the moon orbit the sun, like we said. Now the sun, while the Earth and moon are made mostly of rock, the sun is made mostly of gases. 75% hydrogen, which is a very flammable gas, part of the reason why the sun is burning all the time, and 25% helium. Now, the diameter of the sun is 1.4 million kilometers, about 109 times the size that of Earth. That's where the 109 came from. See, I knew I messed it up somewhere. So, the diameter of the sun is about 1.4 million kilometers. Okay, that is extremely, extremely huge. The sun is also very hot, if you're not aware, especially here in Texas sometimes. The center is about 15 million degrees Celsius, and the surface is about 5,500 degrees Celsius, so 5,500 degrees Celsius. Now, to put this into perspective, the daily temperature of what we, like a general nice cool temperature outside, maybe 70s or whatever, would be about 27 or so degrees Celsius. Now, 5,500 is a lot bigger than 27. So the surface of the sun is extremely, extremely hot. And then the center is obviously 15 million in comparison to 5,500 is quite a bit more. So in fact, even if we were to try and travel to the sun, we would burn up before we even get there because obviously the closer we would get to the sun, the more intense the heat is, and we would not make it very far at all. About 3.6 tons of the sun's mass is being changed into heat and light every second. And this is radiated in all directions. A small amount of sun reaches the Earth and the moon. So if you think, this is not like a flashlight, right? A flashlight, when you turn it on and you point it in one direction, it's going only the direction in which you point it. This is more like a light bulb being turned on without a lamp on it. Okay, without a lampshade on it. When the sun is burning, it sends light in all directions. Okay, it doesn't just shoot one direction towards the Earth or the moon. So, for example, in this picture I have up here, if there were a planet on this side or on this side or on this side, anywhere near the sun, it could have the effect of the sun's light. Okay. So it radiates in all directions and it goes very, very far. I did that one, right? Yes. Okay. So in comparison, all right, this big orange ball, this is the size of the sun. Here's Jupiter. Okay. That is the biggest planet in our solar system. Here's Saturn. These are Uranus and Neptune, I think. Here's the Earth. Okay. You can't even see it when I cover it up because it's so small in comparison. But if I were to, there it is, little tiny speck right there in comparison to how big the sun is. All right. And again, like I said, this will all hit home in the next slide when you go to watch the star size comparison video. But that should be the end of your notes. I'm going to have you watch the video and then you will do your summary. And then on Monday, I believe, no, Tuesday, because Monday is Labor Day. Tuesday, I'm going to have you guys complete the Earth, Moon, and Sun chart. We're going to just kind of fill in the chart in the next page of your notes based on the notes that we just did. But tomorrow, what we're going to do is I'm actually going to give you your first study guide. I will have a video of me going through that. I'll give you all the directions, but just so you know that is coming up. I like to give it to you guys a week ahead of the test. That way you have a whole week to prepare. But before we get ahead of ourselves, watch the star size comparison video. It will blow your minds. I'm sure of it. And then do the summary and you'll be done for today.